Hi. After the episode 1 and episode 2, here comes the episode 3. Form 3 work. And as we said in the previous, the seat is becoming hotter and hotter. And therefore, we are going to welcome the very 7 students we had before as they engage each other on our Luminous Chemistry Stars competition, episode 3. I hope you're enjoying and you have been following and it is helping you. Thank you and welcome. And here are the rules for the contest. Rule number 1, the entry is free, no registration fee, and the contest is open to all high school students in Kenya. Rule number 2, the contest is purely for educational gain and there will be no monetary attachment whatsoever. Rule number 3, the contest has not been sponsored by anybody, not any organization, not even YouTube has sponsored the Luminous Chemistry Star competition. Rule number 4, all winners will be rewarded with non-monetary gifts. And rule number 5, all contestants should be or must be identified as per their respective symbols. Welcome, and the first on the seat is Delta.
Hi guys, my symbol remains to be Delta and I'm ready for the chemistry episode 3 contest.
Very correct. The form 3 work. The seat becomes hotter and hotter and hotter. Kindly relax. Define the term mole.
A mole is the amount of substance that contains Avogadro's number of particles.
Okay, what is that of Avogadro's particle or number of particles?
6.023 times 10 power 23.
That is very correct for 1 point. Okay, you are supposed to convert 24,000 centimeters cubed into liters.
So as you know, 1,000 centimeters cubed is equals to 1 liter. What about 24,000 centimeter cubed? We cross multiply. We find that it is 24,000 centimeter cubed times 1 liter over 1,000 centimeter cubed will be 24 liters.
That is correct. For the 2 points, very correct. Next question. Describe how the concentration of dilute hydrochloric acid can be determined using a standard sodium hydroxide solution.
First of all, we titrate hydrochloric acid against sodium hydroxide. We calculate the moles of sodium hydroxide. After calculating the moles of sodium hydroxide, we use the mole ratio to find the moles of hydrochloric acid. For those moles that we have found of hydrochloric acid, we use them to calculate its molarity.
Okay, that is correct. I will deny you a mark because of not talking of standard sodium hydroxide solution. That is, we titrate the HCl, the one we have no concentration. We titrate it against standard sodium hydroxide. Otherwise, the rest of the story is as you have explained. You are given 6,000 centimeters cubed of nitrogen. You're supposed to convert that gas to moles at room temperature and pressure. Remember, the molar gas volume at room temperature is 24,000 centimeters cubed.
The number of moles we find by volume over molar volume.
Good. Again, that one I give you the 2 points. Which oxide of nitrogen is unstable in air?
Nitrogen 2 oxide, because when it's exposed in air, it reacts with oxygen to form nitrogen 4 oxide.
That is very correct for the 1 point. State and explain the observation that would be made if aqueous ammonia is added to zinc nitrate solution until in excess.
When aqueous ammonia is added to zinc nitrate solution, a white precipitate will be formed due to the presence of zinc ions, and when you add in excess, it will form a colorless solution.
Okay. That one, out of the 2 points, I'll give you one. When you add few drops of aqueous ammonia, you get the white precipitate, as you have said. The white precipitate is zinc hydroxide. If you keep adding until in excess, the zinc hydroxide, being amphoteric, dissolves to form now the complex, the tetraamine zincate ion. Otherwise, you have tried. Name the most appropriate drying agent for ammonia.
Calcium oxide.
Calcium oxide. Why can't we use sulfuric acid?
Because it will react with
ammonia.
ammonia.
That is okay. One physical properties of sulfur oxide.
It is a colorless gas with an irritating and choking smell.
Okay, you've stated even more than one. That's correct. State any 2 uses of sulfur.
It is used in hardening of rubber, and it is used in the contact process in the manufacture of sulfuric acid.
Good, that is fine, among others, like making fungicides and others. 2 chemicals that can be used to prepare chlorine.
Manganese 4 oxide. Pardon the question?
2 chemicals that you can react to form chlorine gas.
Manganese 4 oxide and hydrochloric acid.
And concentrated hydrochloric acid, and that is correct. State and explain the observation that will be made if red and a blue litmus paper are dipped in hydrogen chloride solution.
When a blue litmus paper is dipped in hydrogen
that is a hydrogen chloride solution.
Yeah, in hydrogen chloride solution, it will turn red for some times and be bleached to white, and the red litmus paper will remain red.
Okay, I'll give you one for the red one. Red remains red. Otherwise, with hydrogen chloride, that is solution, that is HCl, it has no bleaching effect. This is not chlorine water. If it was chlorine in water, what you have described is correct. Otherwise, with hydrogen chloride solution, that is HCl solution, the red litmus paper remains red, the blue one changes to red, just that, without bleaching. Next, name the process where you have the long-chained alkanes converted to shorter alkanes. Cracking, yes, be it thermal cracking or catalytic cracking. 2 reagents that can be used to prepare ethane gas.
Calcium carbide and water.
Calcium carbide and water, that is very correct. On the piece of paper you have, you draw for me 2 bromo, 2 methyl propane. I repeat that. You're drawing 2 bromo, 2 methyl propane. The structure, the open structure for that. Okay, display your drawing. Good, that's a 2 bromo, 2 methyl propane, and that's correct for 1 mark. Otherwise, thank you for taking part in this contest.
Welcome.
And the next on the seat.
Good morning. Good morning, chemistry. Hello viewers, my son remains to be Sai, and I'm ready for the 3rd episode of Chemistry Hot Seats.
Thank you very much. As you have said, this is the 3rd episode of Luminous Chemistry Star Competition, Form 3 work. So the seat is becoming hot, but do not panic. Do not panic. Question 1. State the Avogadro's law.
Under the same conditions of temperature and pressure, equal volumes of gases will obtain equal number of molecules.
Okay, will contain equal number of molecules. You are supposed to convert 25 degrees Celsius to Kelvin.
To Kelvin, when we convert, we add 273, 198 Kelvin.
That is, as you display that, that is very correct for the 2 points. Now, next you're supposed to describe how the empirical formulae of magnesium oxide can be obtained.
We burn a given mass of magnesium to oxygen.
Okay.
Oh, sorry, with oxygen. Then
okay, you can use in oxygen.
Okay. Then we weigh the product.
Okay.
Then we subtract the mass of the product from the original mass of the magnesium.
Okay.
Then we use the information to determine the empirical formula.
Well, out of the 2, I'll give you the 1. Remember, as you started, you burn a given mass of magnesium in oxygen. Then you weigh the product. Once you weigh the product, you can subtract the original mass of magnesium. By that, what are you trying to do? You're determining the mass of oxygen that has combined with magnesium. Then, having the mass of magnesium and the mass of oxygen, now go ahead, work out the moles, mole ratios, find out the empirical formula. Otherwise, that is correct. Half the points. Given that 20 centimeters cubed of a solution, we have said 20 centimeters cubed of a solution has 0.05 moles. I hope you've gotten that. 20 centimeters cubed has 0.05 moles. So what is the molality of that solution?
The molality, it is given by moles, you multiply by 1,000 over the volume. Our mole number is 0.05. We multiply by 1,000 over the volume, which is 20. It gives us 2.5 moles.
Okay, can you display that one? Okay, that is fine. Remember, you can use, it's okay. Remember, you can use the first principle, whereby you argue if 20 cubic centimeter has 0.05 moles, what about 1,000? And therefore, you'll multiply 1,000 times the 0.05 divided by 20, and your answer will be, as you have stated, 2.5 molar. That's correct. State the oxide of nitrogen that is referred to as laughing gas.
It is nitrogen 1 oxide.
Nitrogen 1 oxide, otherwise it's called dinitrogen oxide. That is correct. Can you describe how you can prepare a fountain experiment using ammonia gas?
First, you collect ammonia gas in a bottom round flask.
Okay.
Then the water dissolves with water dissolves so much with ammonia that creates a vacuum.
Okay.
Then water rises through the glass tube to fill the vacuum, and it creates a fountain.
Okay, that one is okay. I'll give you 1 point. You have missed somewhere, because when you fill the ammonia into a round bottom flask, you fix a tap. Then you just slightly open to allow a drop of water into the flask that will dissolve all the ammonia. You know, ammonia is very soluble. Then a vacuum is created. Of course, if you open the tap again, a fountain is created. Okay, the next question. Name the catalyst that is used in Ostward's process.
It is platinum rhodium.
Okay, it is a platinum that is anchored in rhodium. Okay, what is the formula of sulfur 6 oxide?
Sulfur 6 oxide is S4.
Okay, display that. That one is very correct. Explain why sulfur 6 oxide is not dissolved directly in water in contact process when you're making sulfuric 6 acid.
The reaction is exothermic. Okay. And fumes are produced.
Yes, that will make the mixture to boil, and then fumes are produced to give acidic mist. So that I give you half the points. Which gas is produced when you expose chlorine water to sunlight?
Oxygen gas.
Oxygen gas will be produced from now the chloric 1 acid when it decomposes in presence of sunlight. State and explain the observation that will be made if chlorine gas is passed through potassium bromide solution.
Pardon the question?
We want to, I want you to state the observation that will be made if you have chlorine gas and you pass it through potassium bromide solution.
The colorless solution turns to orange due to the formation of elemental bromine. The bromide ions are displaced because chlorine is more reactive than bromine. That
is well explained for the 2 points. Okay, you name the process where chlorine is added to ethane. I've said ethane in the presence of the ultraviolet rays, UV rays.
Substitution process.
Yes, that's a substitution reaction. That's okay. State the observation that will be made if bromine water is added to an alkene.
The bromine water is decolorized.
Good. I may deny you the point. So you need to state the original color. So bromine water will change from
brown to colorless.
It will be from yellow to colorless. The next question, I want you to draw the structure of 2-fluoro-but-2-ene. I repeat, 2-fluoro-but-2-ene. Okay, display your answer. Almost correct. But the second carbon, as I can see, it has 5 bonds instead of 4. Otherwise, that mark is gone. But don't worry. And that is the last question of your section.
Thank you.
And the next on the seat.
Hi guys, my science remains to be Sigma and I'm ready for the 3rd episode of chemistry competition.
Very correct. This is the 3rd episode. The seat is hot and hot and hot, and as we do Form 3 work. So kindly relax. Breathe in and breathe out. State Charles' law.
Charles' law states that the volume of a fixed mass of a gas is directly proportional to absolute temperatures at a constant pressure.
That is well said. Very correct. Can you state the conditions we term as room temperature and pressure, RTP?
This refers to temperatures is 25 degrees Celsius or 298 Kelvin and pressure is 760 millimeters mercury.
Millimeters of mercury, which is equivalent to how many atmosphere?
1 atmosphere.
1 atmosphere. That is correct. Even the first question was correct. You're supposed to calculate the relative formula mass of anhydrous sodium carbonate. Sodium is 23, carbon is 12, oxygen is 16.
You get 106.
Okay, you get 106. Can you display that? That's very correct. Without the unit, remember this is the relative atomic formula mass, that is. Again, calculation, you're given 1.12 grams of iron. You're supposed to convert that to moles. You're given that the relative atomic mass of iron is 56. So you're given 1.12, then the relative atomic mass is 56.
You calculate the number of?
The number of moles.
Number of moles equals to mass over molar mass.
Okay.
The mass is
1.12
over
56.
You get 0.02 moles.
Okay, that one is correct. Next question. State one use of nitrogen.
Nitrogen is used as a raw materials in herbal process.
That is very correct. You can also use it to preserve semens in artificial insemination. That one is correct for 1 point. State and explain the observation that will be made if you have aqueous ammonia, you add it to copper-2 nitrate solution dropwise until in excess.
It will form
We're talking about copper-2 nitrate and aqueous ammonia.
It will form a pale blue precipitate.
Okay.
In excess, a deep blue solution will be formed.
Okay, that is correct. In excess, the pale blue precipitate dissolves. That is a key word you missed there. Then a deep blue solution is formed. Remember, you're supposed to explain. What is the pale blue precipitate? Okay, and that's why I'm giving you half the points, because you are to explain. The pale blue precipitate is copper-2 hydroxide. The dark, or what we call the deep blue solution, is now the complex, the copper, we call it tetraamine copper-2 ions. State one way in which nitrogen occurs in nature.
It occurs through nitrates, for example, potassium nitrates.
Okay, any other way?
Free nitrogen in air.
Okay, yeah, very true. That is correct. One use of sulfuric acid.
It is used in manufacture of plastics.
Okay, manufacture of plastics. Okay, that's correct. That's fine. You can use it to manufacture fertilizers, can be used to manufacture detergents, among other uses. Describe the test for sulfite.
You add barium chloride where it will form a white precipitate. Then you introduce an acid which dissolves the white precipitate, forming a gas. Then you use a moist dichromate paper which will turn from orange to green.
That is very correct. I'm tempted to give you 2 points, but still I'll give you half the points. Because when you started, you talked of barium chloride. There is a keyword missing, barium chloride solution. That's what we started with. Otherwise, your description is very okay, very good. Well, what precaution should you take when you're preparing chlorine?
It should be prepared in a fume chamber because it is a poisonous gas.
Okay, that's very correct. State 2 effects of chlorine compounds to the environment.
It turns
2 effects of chlorine compounds into the environment. Okay, no idea? Should I pass or you have an idea?
pass.
Pass, okay. Remember, these chlorine compounds, even like plastic, polyvinyl chloride, they pollute the environment. Some are non-biodegradable. The DDT, those are chemicals again that are used in farming, and again they are also having quite a number of many side effects, even CFC. How can you distinguish between propane and propene?
The use of brine water, where propane will not change its color and propene decolonizes its color to colorless.
Okay. That one is funny there. That one I don't score. Propane is an alkane, propene is an alkene. So the best we can use is bromine water. If you use bromine water with propane, the color will remain yellow. With the propene, the color will go, the yellow color will disappear, among others. So this is, remember, we have been told the question is very open. How can you distinguish? So bromine water is one. You can even burn. Propane will burn with a blue flame, but propene will burn with a yellow flame. That is fine. Next question. One natural source of methane. One natural source of methane.
It decomposes in organic matter, for example, making of biogas from cow dung.
Oh, cow dung. Okay, that one again I don't give you because the way you have brought it out. We are talking of sources of methane. Go direct and state decomposition of organic matter. For example, the cow dung to get biogas. So the very, very last question. Draw for me the structure of but-1,2-diene. That is but-1,2-diene. Okay, can you display that one? Okay, and okay. Yes, that is the structure of but-1,2-diene. And thank you so much. That is the very last question of your section.
Thank you.
And the next on the seat.
Hello viewers, my symbol remains to be lambda and I'm ready for the third episode of chemistry contest.
Okay, thank you. As you have said, third episode of the Luminous Chemistry Stars competition, Form 3 work. So kindly relax, breathe in and breathe out. Are you at ease? Yes, you can say it louder than that. Are you at ease?
Yes.
That one is good. The first question, state Graham's law of diffusion.
Under the same condition of temperature and pressure, the rate of diffusion is inversely proportional to the square root of its density.
That one is very correct. The second question is on calculation. You're given that there is a new, you calculate the new volume of a gas at 2 atm, that is 2 atmosphere, if the original condition was 3 atmosphere and the original volume was 300 liters. I've said we had the first condition of a gas, 300 volumes at 3 atmosphere. Now, what will be the new volume at 2 atmosphere? If you have to change that. Remember, the temperature remains constant for this case.
Okay, the formula is going to be pressure 1, volume 1 equals to pressure 2, volume 2.
Okay, if I may ask, which law are you using? Charles law or Boyle's law? We've said temperature is constant.
Yes.
So we are using, is it Charles law or Boyle's law? Boyle's law. Correct. Be sure it is Boyle's law. Go ahead and calculate.
So our pressure one is 2 atmosphere, and the volume is 300 liters, equals to pressure 2, which is 3, times the volume which we don't have.
Can you display your working? Well, if I look at your working, it's not correct. For that question, therefore, you don't score. But don't worry, it's question number 2. Question number 3 may save you. You're supposed to describe how you can prepare 500 centimeters cubed of 0.5 molar sodium hydroxide solution. You're given that the molar mass, that is the molar mass of sodium hydroxide, is 40 grams. So how can you prepare that? Go ahead.
Okay, 0.5 moles, they are dissolved in 1,000 centimeters cubed, sorry. And what about 500 centimeters cubed? Where we are going to multiply with the relative atomic mass.
Okay, tell us what you have so far. Tell us what you've calculated.
I've calculated the number of moles in 500 centimeters cubed.
Okay, that's correct. So what do you do with the number of moles in 500?
Well, I'm going to multiply with the relative atomic mass.
Okay.
Which is 40. Where we get 10 grams,
okay.
which is the mass.
Okay.
Okay, I'm going to measure 10 grams.
No, you can even now describe without writing. Okay. We have 10 grams. What do you do with the 10 grams?
To the 10 grams, you add some water to it, where you are going to take the mixture of it to where you are going to put the mixture into a volumetric flask of 500 centimeters cube. Then you top up the volumetric flask with the water.
The only part you've taken longer is calculation and all that. But once you have the 10 grams, dissolve it in some water. Yeah, dissolve it in some water. Then transfer it volumetric flask. Add water to the mug. For that, question 3, I've given you 1 out of the 2 points. Don't worry. You're supposed to calculate the number of moles that are present in 16 grams of sodium hydroxide. You're given that is sodium has 23, that is the relative atomic mass, oxygen is 16, and hydrogen is 1. So can you convert 16 grams of sodium hydroxide to moles?
Yes, you are going to add the relative atomic masses, which is 23 plus 16 plus 1, where you are going to get it is 40. The number of moles is given by mass is equals over molar mass, where the mass is 16 over 40. And the moles are 0.4 moles.
Okay, so 0.4 moles. Therefore, you should, next time you can write them bigger. But that one I give you the 2 points. It's correct. And it is very fine. But next time again, write the formula of sodium hydroxide in bold that we may see. State the confirmatory test of ammonia gas.
By use of a red litmus paper, white turns to blue.
Okay, that one I'll give you. You can as well use fumes of hydrogen chloride gas. And when the two gases meet, they form a white cloud, that is ammonium chloride. Describe how nitrogen can be isolated from the air.
Okay, it is first passed through a concentrated potassium hydroxide or sodium hydroxide, where carbon 4 oxide is absorbed. After that, it is also passed over heated copper and oxygen, it's absorbed. The remaining gas, it is passed under a drying agent, which is sulfuric acid, and it is dried where the nitrogen is 99% and some traces of argon.
Okay, that one is okay, and I give you the 2 points, but just some few correction. When you pass the air over heated copper, the oxygen will not be absorbed, but it will react with copper, and then the nitrogen you get, it has the traces of argon, but not necessarily 99%, but almost 99%. Otherwise, that's correct. One use of nitric 5 acid.
It is used in manufacture of drugs and dyes.
Yes, also nitrogenous fertilizers, among others. Name a compound of sulfur that smells like a rotten egg.
Hydrogen sulfide.
Hydrogen sulfide, that is correct. Describe the test for sulfate ion. Sulfate ion.
Okay, you introduce barium nitrate where a white precipitate is formed. Then introduce an acid where it does not dissolve.
Okay, you introduce barium nitrate solution, not just barium nitrate, a barium nitrate solution, and that is okay. One use of chlorine.
It is used in manufacture of hydrochloric acid.
Yes, that is it. So it can be used to manufacture the polyvinyl chloride, treatment of water, that is killing germs in water, among others. Describe the test for chloride ions.
It is tested by lead 2 nitrate where white precipitate is formed of lead 2 chloride.
Okay. Are you done with that one?
Yes.
I give you half of the total points because you use lead, you use like you've talked of lead 2 nitrate solution. Again, remember to say it is solution. A white precipitate is formed, then you do warming. Once you warm, the chloride will dissolve. The white precipitate dissolves. You name the process where you have methanol converted to methanoic acid when you add acidified potassium manganate 7.
Oxidation.
That is oxidation from an alkanol to alkanoic acid. The next one, how can a burning distinguish propane from propene?
Propane burns with a blue flame, while propene burns with a yellow flame.
That is correct because propane is saturated hydrocarbon, propene is unsaturated. That mark is okay. The very last question, using the pen you have, you draw for me the structure of pent 1, 2, 4 triene. I repeat that. You're drawing the structure of pent 1, 2, 4 triene. Okay, can you display that one? Pent 1, 2, 4 triene. Which is your carbon number 1?
This one.
Okay. Then that has 4 bonds, the others correct. Good. Display that one once again. That formula is very, very correct for the 1 point. Otherwise, thank you so much for taking part in this competition.
Welcome.
And the next on the seat.
So guys, my symbol remains bitter and I'm ready for the 3rd episode of the contest.
Okay, thank you. As you've said, this is the 3rd episode of Luminous Chemistry Stars competition, Form 3 work. Don't panic, take it easy and just relax. The first question, define the term isomers.
These are compounds with the same molecular formula but different structural formula.
That is very correct. You're given negative 300 degrees Celsius. You're supposed to convert that to Kelvin. You have a piece of paper there. You can do your working there.
Negative 27 Kelvin.
Negative 27. That is correct. The next question. Describe how you can determine the percentage purity of calcium carbonate. How can you do that?
Add excess HCl to the calcium carbonate.
Okay.
Then titrate it using a base, which is sodium hydroxide.
Okay. Well, that is a back titration, a quite a procedural step there. Like you've started, you react calcium carbonate, the impure one, with excess HCl. Then this is back titration. What you're titrating is the unreacted HCl. The unreacted HCl, you titrate it with a standard sodium hydroxide. And with that, you'll be able to determine the excess HCl. With the excess HCl, you can determine the calcium carbonate that reacted with the HCl. Go on to use that data to calculate the percentage purity. Quite a procedure there. But I give you half the points. That is 1 out of the 2. How many moles are there in 2.4 grams of magnesium? You're given that the relative formula mass of magnesium, that's the RAM, is 24. So you are supposed to calculate the number of moles.
0.1 moles.
Okay, can you display your working? Okay, I give you half the points. I know what you've done. You've done the cross multiplication, but at least we want to see 2.4 somewhere, divide by 24, because that is the marking point for that. Which method can you use to collect nitrogen in the laboratory?
Over water method.
Yes, you can use over water method. It is insoluble in water. Describe a simple experiment that you can perform to prepare ammonia.
Mix ammonium chloride with calcium hydroxide. Transfer it to a round bottom flask, which is in a tilted position. Then heat it.
Okay, then how do you, for example, if I need this gas dry, what do I do?
You pass it through calcium oxide, which is a drying agent.
Then how do I collect the gas?
Upper delivery.
Yes, that's correct for the 2 points. But remember, the two substances are mixed inside the flask. Kindly take it easy. We go on. Name one nitrogenous fertilizer.
Ammonium sulfate.
Ammonium sulfate, among others. Name the process for the extraction of sulfur.
Frach process.
Yes, the Frach process. Okay, the next question. Describe how sulfur oxide gas from the contact process can be prevented getting into the atmosphere.
Sulfur oxide is passed through a chimney which is lined with calcium hydroxide, a process called scrubbing the gas.
Okay, so what product will be formed? If, for example, you pass sulfur oxide through the chimney containing calcium hydroxide, what product do you get?
Calcium sulfate.
Calcium sulfite. I give you half the points, no big issue there. Because when you're talking of the chimney, it is the chimney fitted with calcium hydroxide solution, not solid hydroxide solution. Next is the color of chlorine gas.
Green yellow.
Okay, yellow green or green yellow as you're saying. The next one, state the observation that will be made if magnesium is dropped into a mixture of hydrogen chloride gas in tetrachloromethane.
There will be no effervescence formed.
Okay.
Because the mixture does not ionize to produce hydrogen ions.
That one I'll give you the 2 points. Basically, the hydrogen chloride gas will not ionize in tetrachloromethane. It will just dissolve. And that means that solution will not be acidic, and therefore magnesium will not react. Name the process where alkenes are converted to alkanes using hydrogen gas and a nickel catalyst.
Hydrogenation.
Okay, that's hydrogenation. That's very correct. What is a hydrocarbon?
A compound that consists of hydrogen and carbon only.
Only, that's correct. Draw for me on the piece of paper you have. Your drawing, can use the back side of the paper. You're drawing 1,2-dibromoethane. 1,2-dibromoethane. Correct. That's the formula of 1,2-dibromoethane. Otherwise, thank you for taking part in this competition. All the best.
Thank you.
And the next on the seat.
Hello guys, my sign is Omega and I'm ready for the third episode of the Hot Seat.
Thank you so much. As you have said, this is the third episode of the Luminous Chemistry Star Competition, Form 3 work. So, as we said, the seat is getting hotter, so kindly relax. Take it easy and relax. The first question, state Boyle's law.
Boyle's law states that under the same condition of temperature, the volume of a given mass of a gas is inversely proportional to its pressure.
Okay, that means the temperature is constant.
Yes.
That is correct, and that is 1 point given. What is the relationship between rate of diffusion and time taken for a gas to diffuse?
Time taken is inversely proportional to its rate of diffusion.
That one is correct. That question goes with 2 points, and that is fine. Question number 3. You're supposed to describe how you can prepare 250 cubic centimeters of 1 molar potassium hydroxide solution. You're given the molar mass of potassium hydroxide is 56 grams per mole. So how can you describe how you can do that?
Pardon the question?
Okay, we want to prepare 250 cubic centimeters of 1 molar potassium hydroxide. How do you prepare that?
You dissolve 14 grams of the potassium salt in water, put it in a volumetric flask and add water to the point.
Okay, what is the capacity of the volumetric flask?
250 ml.
Okay, 250. For that one, I can give you half the total mark. Remember, as you have calculated, we need to use 14 grams of potassium hydroxide. Now, we need to dissolve it in some distilled water. You have missed the word distilled water. Then once it dissolves, you can transfer it to a 250 ml volumetric flask. Then from there, you add water to the mark. Remember even to rinse the beaker you had before, and of course transfer it there. So that otherwise that is fine. How many moles are present in 100 cubic centimeters of 0.5 molar sodium chloride? I repeat the question. How many moles are present in 100 centimeters cubed of 0.5 molar sodium chloride?
So to find the number of moles, we use the volume of moles is equals to volume times molarity over 1,000. .05 moles.
Okay, correct. That one I'll give you. Remember, instead of the formula, you can use what we call the first principle. You argue out 1,000 centimeters cubed has 0.5 moles. What about 100? And then you go multiplying 100 times 0.5, you divide by 1,000. You get the 0.05 moles. That is very correct for the 2 points. Which oxide of nitrogen is brown in color?
Nitrogen 4 oxide.
That is very correct. Give a very brief summary of the Haber process.
Purify nitrogen and hydrogen to remove impurities that will poison the catalyst. Pass them to in the compressor where they are compressed between 200 and 300 atmospheres. Heat the gases in a heat exchanger and pass them to the catalytic chamber where iron is used as the catalyst and ammonia is formed. Return the ammonia in the heat exchanger to cool the mixture. Condense the ammonia in the condenser where it is liquefied to form ammonia and stored in a glass.
Okay, that one is very nice. So what is the temperature at the heat exchanger? Because you have said heat without talking of the temperature.
500 degrees Celsius.
Okay, what are the optimum conditions for Haber process?
Use of a catalyst.
Okay, the optimum conditions now there. So I'll give you, actually you've done it very well, but I'll give you half the total points. One, the catalyst that we use in Haber process.
Finely divided iron.
Yes, the iron powder, that is very correct. You're supposed to name a compound of sulfur that will change the potassium dichromate paper from orange to green.
Sulfur 4 oxide.
That is very correct. State two allotropes of sulfur.
Rhombic sulfur and monoclinic sulfur.
And monoclinic sulfur. That is very correct. So which method can you use to collect chlorine gas?
Downward delivery.
You can use downward delivery. Why do we use downward delivery?
Because it is denser than air.
That's very correct for the whole 1 point. State and explain the observation that will be made if you have green leaves, then you dip them in chlorine water.
The green leaves will turn to white due to the presence of chlorine 1 acid that has the bleaching characteristics.
Okay, where does the chloric 1 acid come from?
It combines with the oxygen present.
Okay, for the total points of 2, I'll give you 1, but your description is okay. It's not chlorine 1 acid, it is chloric 1 acid, and then the paper will be bleached. Chlorine water is because of chlorine dissolving in water. That is basically that. 1 point for that. Name the process where thin molecules converted to giant molecules.
Polymerization.
Polymerization, that's correct. State one use of alkanes.
Used as a source of hydrogen in cracking process.
Also, rather, you can also use them as fuel. That's correct. Using the pen you have, give me the structure of propyne.
Propyne meaning it has a triple bond with 3 atoms of carbon.
Okay, can you display that? Okay, that one is very correct. Thank you so much, and that is the end of your section of the hot seat of Luminous Chemistry Stars.
Thank you.
And the next on the seat.
Back on stage. Hi guys, my sign remains to be Alpha, and I'm ready for the 3rd episode of the chemistry contest.
Very correct. Thank you so much. The 3rd episode entails Form 3 work. So take it easy and relax. Then do not panic. First question. State the Gay-Lussac's law.
It states that when gases react, they do so in volumes that bear simple ratio to one another and to the volume of the product if gaseous as constant temperature and pressure.
Wow, that is excellent. That's excellent. The next one, you're given 700 kelvins. Can you convert that to degrees Celsius? 700 Kelvin to degrees Celsius.
.427°C.
Okay, 427 degrees Celsius is correct for 2 points. Describe how you can prepare a half a liter, that is 500 centimeters cubed, of a 0.5 molar solution. You're given that the stock solution, the original solution, is 2.0 molar.
You prepare it by diluting the 2.0 molar stock solution in 125 centimeter cubic of water.
Okay, what volume are you diluting?
125 centimeters cubic.
You're having, okay, how did you work out the 125? Can you display your working? Okay, molarity 1 times volume 1 equals to that. You got 125. So what is this 125?
This 125 is the volume that you are supposed to add as dilute water in the stock solution.
Okay, you have really tried. I'll give you half the points, but you've tried. The working you've done is very correct. So all you need to tell me now is you measure 125 centimeters cubed of the stock solution, place it in a 500 ml volumetric flask, add water to the mark, and that will be very correct. So how many moles are there in 7.1 grams of chlorine gas?
.2 moles.
Okay, can you write it down, then you display it? The question is, how many moles of chlorine gas are there in 7.1 grams? So I want you to write for me the formula of chlorine gas, that is chlorine molecule. Okay, chlorine gas. How many atoms of chlorine?
2.
2. That means the molecular mass you're using is not 35.5 but 71. With that, you miss the whole question. State any one use of ammonia.
It is used in the manufacture of nitrogenous fertilizers.
That is correct for the 1 point. The next question. Give a summary of the Ostward's process.
Ammonia and air is passed through the purification chamber where dust particles and other impurities that may poison the catalyst are removed. Then it is air, and then it is passed through the compressor. It is compressed up to 9 atmosphere, and then taken to the catalytic chamber where it combines with oxygen to give nitrogen 2 oxide, and then passed through the heat exchanger to cool the mixture, and more air is added where nitrogen 2 oxide combines with more oxygen to give nitrogen 4 oxide, and in the absorption chamber hot water is added to give nitric 5 acid and nitric 3 acid.
Okay, I give you half the points, but I want to ask you, how do you convert now the nitric 3 acid to nitric 5 acid? Okay, remember the mixture still has oxygen, so the oxygen will oxidize it further to nitric 5 acid. Again, you did not mention the catalyst. That's why maybe I denied you the other 1 point. So the catalyst used is platinum, that is anchored in rhodium, or platinum rhodium. Is that the case? Yes or no? Next question. State one effect of nitrogenous fertilizers to water bodies.
It encourages the rapid growth of algae that remove the oxygen in water that leads to death of aquatic animals.
So what do you call that process?
Eutrophication.
Eutrophication. That's correct for 1 point. The best catalyst to be used for contact process.
Vanadium 5 oxide.
Okay, why not platinum?
Vanadium 5 oxide, it is cheap, hence is not easily poisoned.
Okay, those are 2 points. It is cheap, and the other one, it's not easily poisoned by. Describe how sulfur can be extracted from the ground. You can give it a very short summary there.
Use of fresh process, whereby due to its low melting point, 3 concrete pipes are dug underground where the sulfur deposit is, where the inner pipe hot compressed air is passed, then the outer pipe superheated water is passed there, and the other pipe is for molten sulfur.
Okay, so the inner pipe, the middle pipe will now force the molten sulfur out. There are 3 concentric, that is interlocked pipes, maybe not necessarily concrete. Next, you name one way chlorine occur in nature.
Rock salt.
Rock salt, yes. Sodium chloride, that's rock salt. Describe briefly how you can prepare hydrochloric acid.
You can burn hydrogen gas together with chlorine gas, and it will produce hydrogen chloride gas. So you dissolve it in water to give aqueous hydrochloric acid.
That one is fine, I'll have no issue. Like when you're dissolving the hydrogen chloride gas, you have the glass beads that will increase the surface area and all that, but you have described it well. Name the process where ethanol is converted to ethene using concentrated sulfuric acid.
Dehydration.
Dehydration, that is correct. Name the product that will be formed when ethane with A is completely burnt in air.
Carbon dioxide and water.
That is correct. On the piece of paper you have there, you draw for me as the structure of 2-methylbutane. 2-methylbutane. Display that. Okay, with that I give you 1 point. Otherwise, thank you so much for taking part in this competition.
Thank you.
After the very stiff competition, the competitors were on this very same seat. Actually, I can still feel the seat is hot. Now, I'm here to give the results. Remember, we've already done episode 1, episode 2, and now we've done episode 3. With that, now we're going to add cumulatively episode 1 and 2 as we did before. Now we do add the episode 3 to see where are we as we await episode 4 next. Delta has scored 17. Delta initially had 48, so cumulatively Delta has 65. Psi, the competitor with the symbol psi, in the first two competitor had 51, now has 15, making that to 66. We go to the next competitor, Sigma. Sigma scored 48 in the previous two episodes. In this one, Sigma has 14, and Sigma has claimed 2 points that we denied her in the previous. So in total, Sigma has 64. The next competitor is Lambda. Lambda cumulatively had 51 in the first two episodes, then has 15, making that to 66. The competitor with the symbol beta, initially the first two episodes, 53 points, adding to 17 in this episode 3, and that makes 70 for beta. Omega had 46, then the episode 3 has 17, that makes 63. And finally, Alpha. Alpha scored 50 in the first two episodes, then this one, Alpha has 15. That makes 65. And the competition continues.
Hi viewers, I'm here, Sai, asking you to vote for me, support me, and don't forget that Dr. Sirme is the best.
Hey guys, my sign is Omega. Please vote for me. And I'd like to challenge all the students to join the hot seat. Join us. Maybe by yourself you will realize how the seat is really hot.
Hi guys, I'm Delta, and for today I have an encouragement for students. Please take chemistry as a simple subject. Know that whenever you create in your mind that chemistry is hard, it will always be hard for you. So please take it like any other subject, and please follow Dr. Sirme because he's the best teacher. Thank you.
Hello guys, it's Beta here. Please subscribe to this channel and vote. Remember, Dr. Sirme is the best.
Hi viewers, my sign remains to be Alpha. Hey, and I'm always your creative girl, making you smile. Always asking, vote for us, and remember, hit the bell. Dr. Sirme, the best. Thank you.
Omega,
Lambda,
Sigma,
Delta,
Alpha.
Psi, Beta.
Don't miss out on our next episode. See you.
Finally, do not forget the Dr. Sirme initiative for the very needy students. Kindly support the student whose detail is given, and God will bless you. For the student who may need virtual chemistry or mathematics classes, that is the high school students, kindly link with me through the WhatsApp number that I have attached. Thank you so much.
My tie. Nalinyonga. Put you back again on stage.
You can tell them.
Bye-bye.
Guys, hi guys.
Ni poema anasema.
Hi guys.